welcome back. My name is Satyajeet Sahu and we are in our IIT Kanpur previous year question session. Okay, so we were doing monsoon series. So that series is over now, and now we are going to start what IIT Kanpur previous year question sessions. Okay, and in series we will solve the previous year questions of your IIT Kanpur. So let us first welcome our participants. So welcome Amir, Aftab, Rasmita, Samriddhi and all. Okay. So a short introduction about myself. My name is Satyajeet Sahu. I have done my BTech in Civil Engineering from IIT Kharagpur. I have also done my Master in Structural Engineering from IIT Kanpur only. Okay. Then I have been selected into many of the PSUs through GATE. Okay, and I have been teaching for more than 10 years now, and I teach all the civil engineering subjects, and also I teach strength of material and fluid mechanics, which is common subject for your civil and mechanical. Now, some information about your this week sessions. So today and tomorrow, okay, today and tomorrow we will have what? Fluid mechanics. We'll have what? Fluid mechanics. I'll request the technical team to just reduce my size because I'm looking little huge. Okay, so I'll request the technical team to just reduce my size so that I can start teaching. Okay. Okay. Good evening, Paramesh. Good evening, Vivek. Good evening, Rajashree. Good evening, Lakshmi. Good evening, Aki, Saurabh Sri. So many participants are there, so I am very happy that all of you are there. Thank you very much, Rahul. Okay, Juhi, okay, TTV logs. Okay, so many students are there. Thank you very much. So today and tomorrow we'll be solving questions of what? Both civil and mechanical. Okay. So the coverage will be such that I'll be solving questions common to both civil and mechanical. Okay. And we can say that fluid mechanics, the portions are almost similar. So, and for civil engineering students, okay. So on 10th of August, we'll have irrigation engineering, and on 12th and 13th, we'll have highway engineering. Okay. So let us not waste any time and start the class. Okay. Let us not waste any time and start the class. Okay. So first of all, when we are discussing a previous year question, understand that we will not be able to complete all the concepts. Okay. From 10, mechanical subjects will be there, right? I just informed about the civil subjects. There will be mechanical subjects also. Okay, for that you can visit our official YouTube channel. Okay, and then there we will be conducting and we will announcing the other sessions also. Okay, so from 10th also there will be previous sessions for mechanical. I just informed for the civil students. Okay, and today and tomorrow we will have common session for what? Fluid mechanics. Okay, so let us focus on today's session and not waste any further time. So when I am telling that we will be solving previous year questions, when we are solving previous year questions, obviously we cannot cover everything, right? We cannot cover everything. And when we say that we are discussing IIT Kanpur previous year questions, in the last 20 years, IIT Kanpur has conducted in 2001, 2007 and 2015. Okay. So now first of all, we have to understand that it is not that if you are discussing IIT Kanpur questions, they will repeat the question. Do you think the IITs or IIScs will repeat the questions in the examination? Okay. They will repeat, but irrespective of the years, right? They will repeat, but irrespective of the years. So, we will be discussing this question. Okay, we'll be discussing these questions, but don't think that they will ask these questions only, right? So, what will be my model of teaching? What will be my model of teaching? I will not only solve the previous year question, but also give you an idea of other important topics, okay, which can be asked from the fluid mechanics. Okay, so my focus won't be only previous year question. We'll be solving the previous year questions of 2001, 7 and 15, but along with that I will give you an idea of what type of questions can be asked from each and every chapter. Okay, so today we will be discussing first chapter, that is what? Your viscosity and basic properties. Okay, viscosity and basic properties we'll be discussing. Then we'll be discussing something on what? Your hydrostatic forces. Okay, we'll be discussing on hydrostatic forces. Okay, then we'll be discussing pipe flow. We'll be discussing pipe flow, and then we'll discuss dimensional analysis. So these questions and the related theory, okay, I will not only solve questions, but I will discuss the relative theory also. Okay, so these things we will cover today, and tomorrow we will have little, heavy things, right? Tomorrow we'll have little heavy things, like we will have fluid kinematics, okay? And I will teach you many concepts of fluid kinematics along with the previous years. So tomorrow we have fluid kinematics, we will have fluid dynamics also, right? We'll have fluid dynamics. Okay, in dynamics we'll study laminar flow and incompressible flow, and then boundary layer, okay, and then boundary layer theory, okay, and then your hydraulic machines. So we can say that tomorrow we have little what? Heavy topics, right? Tomorrow we'll have little heavy topics. So to start with, I didn't start with heavy topics so that you will feel little burdened, right? So I thought that let me today take, comparatively lighter topics, right? So that you get acquainted with the numerical solving, right? And then by tomorrow we'll be ready for what? For these heavy topics. So hope all of you understood the flow for this next 2 days. Yes or no? If you understood, please write yes in the comment section, right? So today, that is 8th of August, we'll be discussing this thing, and then 9th of August, we'll be discussing fluid kinematics, dynamics, boundary layer, and your hydraulic machines. Okay, thank you very much. Let us start with the viscosity. Okay, let us start with viscosity. In viscosity, the most common question they ask is what? About the Newtonian law of viscosity. And what was that? The shear stress is equal to the dynamic viscosity into what? Into the velocity gradient. Into what? The velocity gradient, right? Hello, Naivedya, Akans, Ans, everyone welcome. Now, from this, what type of questions they can ask? They can ask you very basic questions. Like suppose if I tell that u is equal to, 0.5 y square, okay, minus 0.5 y square minus 0.25 y, okay, and then I tell that find your shear stress, at y is equal to 0.5 meter if your mu is equal to, suppose I am giving 9 pH. Now we'll solve these questions. We call this question, don't panic now. But before that, some very objective types of questions they can ask in the examination. Like, they will ask you the units of these things. They will ask you 1 mark units on what? This particular mu. What is mu? Mu was your dynamic viscosity, right? What is mu? Mu is your dynamic viscosity. Okay? Mu is your dynamic viscosity. Now you see, this is your shear stress. Now shear stress will have unit what? Newton per meter square, right? And then this is du by dy. Du is what? Change in your speed. So it will be meter per second. Change in speed will be having unit of what? Meter per second. And then dy will have unit of what? Meter. Yes, dy change in distance. So this gets cancelled. I get what? 1 by s. So from here I can say mu is what? Newton second per meter square. Newton second per meter square. Now if I convert into Dian. Okay, thank you Kamlesh. I obey your instructions and I will solve all the previous question of civil and mechanical. Thank you for instruction. Any more instruction from Mr. Kamlesh? Please mention in the comment section. Hello Survi, welcome. Okay. By centimeter square. Okay. So now 1 Newton is what? 1 Newton is 10 to the power 5 Dian. Okay. And then 1 meter square is how much? 1 meter square is how much? 10 to the power 4 centimeter square. Okay, very good, very good. Now, try to understand. If I put here, what will happen? 10 to the power 5, okay, Dian per second, and then 10 to the power 4 centimeter square. This becomes what? 10, and this unit is what? This is your PYQ. This is your PYQ, right? So I can just erase everything and I can say that your dynamic viscosity is having unit of what? Newton second per meter square, and this is in Dian second per centimeter square, that is PYQ, how much? 10. So 1 Newton second per meter square is equal to 10 PYQ. In 1 mark question, they ask these things a lot. And we know that this is your dynamic one. What is your kinematic one? Kinematic one is dynamic by rho. Dynamic by rho. So can you give me the unit of kinematic? Can you give me the unit of kinematic viscosity? Can you give me the unit of kinematic viscosity? So this is the question asked in your GATE. So 2001 they asked this question, right? In 1 they asked this question, that the SI unit of what? Kinematic viscosity. Namaskar Vidya, namaskar Bhavya. Okay. So what is the SI unit of kinematic viscosity? So here, this is equal to mu by rho. So mu we got what? Newton second per meter square. And rho is what? Kilogram per meter cube. Okay, kilogram per meter cube. And what is your Newton? Newton is kg meter per second square, right? Yes. So from here you see kg gets cancelled. If you bring this meter cube above, then what will happen? I'll get a meter here, okay, and then this second get cancelled. I get what? Meter square per second. Okay. So this is the way I am going to discuss the previous year question. Hope you got the idea how I am going to discuss the previous year question. I will not be only discussing the previous year question, but the related theory to that. Then it will be more helpful to you, right? Then it will be more helpful to you. So it is what? Meter square per second. Now you see, 1 meter square per second is what? 10 to the power 4 centimeter square per second. And this entity is what? Tell me. What is this entity? What is this entity? Centimeter square per second. What is this known as? Tell me. Centimeter square per second. What is this? Please write in the comment section. Yes, this is Stokes. So you should remember that. Your 1 meter square per second is equal to 10 to the power 4 Stokes. And Stokes is also the unit of what? Kinematic viscosity. And dynamic viscosity is what? Newton second per meter square. And this is equal to 10 to the power 1 PYQ. 10 to the power 1 PYQ. Right? They can even ask you what? The dimensions, right? In 1 mark question. They can even ask you what? The dimensions. Suppose I ask you dimensions of your mu. Can you give me the dimensions of mu? Come on. Please give me the dimensions of mu. Please give me the dimensions of mu. These are all potential 1 mark question. Then we'll be going to the 2 mark question. Don't worry. Then we'll go into 2 mark questions also. Potential 1 mark questions. Very easy. You see, this Newton second per meter square. I can write down this as what? Newton is kg meter per second square. Okay. And then this is meter square and this is second. So see, this get cancelled, this get cancelled. I get what? Kg per meter second. So kg is mass, m to the power 1. Meter is your length dimension, so it will -1. And then t, then -1. So, and along with units, they ask what? Dimension. So you can easily find dimension. And if they ask you for the kinematic one, it's very easy. You don't have mass here, then length square t to the power -1. Okay. So these are all the potential 1 mark questions and we discussed in details. Now coming back to 2 mark question which they can ask in the examination. They can ask in the examination, okay? So coming back to this question. How to solve this question? First of all, what is du by dy? Du by dy is how much? I can say it will be 2 into 0.5y minus 0.25. So how much you're getting this? You're getting this as 2 into your 0.5. Okay. So how much is this value? Tell me. How much is value you're getting? When you put y is equal to 0.5, how much you're getting this du by dy? Please write in the comment section how much you're getting. Let me calculate also. 0.5 into 0.5 into 2. You're getting 0.25, right? Okay. Please give me du by dy. Okay, I'm asking du by dy, not asking the shear stress. I'll ask in the end. So how much you're getting du by dy? Yes, you're getting du by dy as 0.25. Okay, 0.25. Okay, now very good. So now if you want to find out the shear stress in Newton per meter square, that will be how much? The dynamic viscosity is given 9 poise. In standard units, it will be how much? 0.9 Newton second per meter square, right? Because 1 poise is 0.1, right? See, 1 Newton second per meter square is 10 poise. So 1 poise will be what? 0.1. So this into, I can say 0.25. So getting how much? 0.225 Newton per meter square. So this is a potential 1 mark question which they can ask from what? Your Newtonian law. They will give you any profile. They will give you any profile, right? See, I gave you this profile. Okay. They will give you some other function of u. You can differentiate it. Yes. Then you can put the value of y at which they are trying to ask you the shear stress. Right. This is the most basic type of question which they can ask you. Next, the next basic type of question they can ask from this viscosity is what? That is your, if we have a fixed boundary, yes, and then we have a plate like this. We have a plate like this, right? And then it is moving with a particular speed, suppose v. Okay, so the force required to move this plate at this particular speed. Now what is the theory behind it? What's the theory behind it? That there is fluid, it is moving in fluid, okay? So this is the distance h, and what I will do, tell me, I will ask you, I am not just solving. Tell me what will be the velocity profile here, what assumption I will do, what will be the variation of the velocity, tell me. What will be the variation of velocity, tell me. Yes, it will be linear. I will assume it to be linear. Very good. So if this is linear, okay, I can say the change in velocity by change in your distance. See, change in distance is how much? H, right? Yes. And you see this plate is moving with velocity v. So here the velocity will be v, and here the velocity will be 0 at the fixed boundary. So it will be v minus 0, giving me how much? V by h. So this is what? Okay. If not given, mostly they will not give only. In case of plates, they don't give. They assume that you will assume it to be linear. Okay. So they assume that you will assume it to be linear. Okay. So du by dy you got, right? And then mu you know. So I can say the shear stress will be equal to mu into v by h, and the force required will be how much? It will be simply mu into v a by h. Okay. So I'm not solving any question in this. Why? Because in the previous year in IIT Kanpur they have not asked this question. Tell me, IIT Kanpur has not asked this question. Does that mean that they will not ask this time? No, they will ask, right? They will ask you, right? So therefore, I am not only discussing the previous year question, also the potential question and the theory behind that, right? Let us solve a question also, right? Let us solve a question also. Suppose I am giving you, that this plate area is 2 meters square, right? Suppose plate area is 2 meters square, and this gap This I can say is the gap between the plate and the fixed boundary. Suppose the gap is, suppose 35 centimeter. It is 35 centimeter. And the mu is, suppose, your 8 PYQ, okay, and the plate is moving with a velocity of 3 meter per second. So can you give me the force required? Calculate and give me. Please give me the force required. Please give me the force required. So 40, it suddenly decreased. So 36, 37 students are watching the session, and I am very happy that all of you have come. So please attend this series, and tomorrow it will be more interesting because tomorrow I will be taking the heavier topics, right? Like kinematics, dynamics, okay? So you will find it. Okay, so getting 13.71, okay? Very simple. 8 PYQ means in standard units 0.8 Newton second per meter square. Velocity is 3, area is 2, and you see this h you should put in what? You should put in meter. You should put in meter. Try to understand. Everything you have to put in standard units. So getting how much? 13.71 Newton. Okay, 13.71 Newton. So this is what? A very standard question, right? This is a very standard question. Okay. Now, more questions can be asked from this, but I solved the most probable, I think. Yes. Now, in the YouTube, I have taken a session on what? Viscosity and Newtonian law. Okay. I have taken a session viscosity and Newtonian law in your monsoon series. Okay, more questions you can solve from there. They're not previous year question, but I can say they're practice questions for you based on this particular principle. Okay, very good. Now you see a very basic question was asked in 2001. It is given a static fluid. A static fluid. Can you just answer this question? Okay, it's a very common question, but still I expect you to answer this question. A static fluid can have what? Tell me. Which of the options is correct? Tell me. A static fluid can have what? Tell me. Which of the following options is correct? It's not directly related to, I can say, your viscosity, but a very basic question. Yes, the answer is B. The answer is B. See, fluid means there is no shear stress. That is the basic definition of fluid. Fluid means there is no shear stress, right? Yes. And I can say, if you consider, suppose this is the top surface, right? And we have a fluid particle like this. Then what happens, you see? Then there is equal pressure from all sides. And this is what? I can say this is, I can say compressive, or I can say this is what? Your negative normal stress and then zero shear stress. A very basic question I discussed. It was asked in 2001. Let us move to, for viscosity we have discussed previous year question. Yes. And we also discussed some potential questions. Okay. Now next is hydrostatic forces, right? Hydrostatic forces, okay? Hydrostatic forces. So hydrostatic forces on surfaces, okay? Hydrostatic forces on surfaces, okay? Now first of all, I'll give you some background theory and then we'll solve questions, right? Okay. First of all, I'll give you some background story. So what type of questions they will ask from hydrostatic forces? Okay, so here we have surfaces. Okay, suppose this is the top surface of the fluid. Okay, you can say it is open to atmosphere. Now we can have planes, these surfaces, or I can say planes. Okay, we can have a vertical plane, right? Okay, we can have a vertical plane like this. This is a vertical plane. See, vertical plane will look how? If you see from side, it will just look like a line, na? The vertical plane will look like a line. Or if you say from other angle, this I can say is the vertical plane, right? This is a vertical plane, okay? It's like you suppose this is a plane, and suppose I am inside fluid, okay? I am inside fluid, okay? I am inside fluid. This is what? A vertical plane, right? Suppose I am inside fluid. Suppose I am inside fluid. This is what? This is a vertical plane, right? Understood everyone? This is a vertical plane. This is also a vertical plane. Because see, if you see this from this angle, it will look like this, right? If you see this from this angle, it will look like this. This is what? A vertical plane, right? This is a vertical plane. So they will ask you the hydrostatic forces on a vertical plane. Then they can ask on a inclined plane. They can ask on a inclined plane. The inclined plane will be how? Tell me. It look like this. This is a vertical plane. This is an inclined plane, right? This is a inclined plane. So the inclined plane, if you see from side, it will look something like this, right? You see? Inclined plane. This is an inclined plane. It is inclined at a particular angle with the horizontal, right? And suppose this angle is suppose theta. This angle is suppose theta. The angle is suppose theta. This is what? Your inclined plane. They will ask questions on what? Your curved planes, right? Then they will ask questions on your curved surfaces. On curved surfaces. See, they can also ask question on horizontal surface, but the chance is very less. Horizontal surface is what? I can say this is the horizontal surface, right? See, this is vertical, this is horizontal, this is inclined, and this is curved. Understood? Vertical, yes, inclined, horizontal, and curved. Okay, so they can ask all these questions. Okay, so suppose we have a vertical. Suppose we have a vertical. Okay, suppose we have a vertical plane. Suppose it's a rectangle. It's a rectangle. It can be a square also. It can be a circle also. It can be a triangle also. It can be any shape. Okay, but suppose I'm taking a rectangle. Then how to find out the pressure force? The pressure force. That's very easy. You find out the pressure force. Now force is what? Force is stress into area, right? So that means I will take pressure and I will multiply area to it. I'll take pressure and then I will multiply area to that. Now you see, pressure is different at different points, right? So where I will take the pressure? I will take the pressure at the centroid of this particular area. Okay, so this is the centroid. So suppose this is what? The depth of the centroid. Suppose I am giving as h bar. So what will be the pressure? So I'll say what? Pressure at centroid, or I can say h bar. So what will be the pressure here? Very easy. Suppose it is water. With water, I can say the pressure here will be what? Gamma W into h bar. Yes, gamma W h bar will be the pressure, and this will be equal to gamma W h bar into area. That will give me the total pressure force. That will give me what? Total pressure force. Like this question was asked in GATE. You see, it was asked in Civil 2015, 2 marks. What is given? We have a triangular gate, okay, whose base is 2 meter and height is 1.5 meter. It lies in a vertical plane, right? Then what is given? The top vertex is 1.5 below the surface of a tank. It's inside a tank which contains oil of specific gravity, how much? 0.8. Okay, so it's not inside water, it's what? Inside oil of specific gravity, 0.8. Okay, so they're asking you the hydrostatic force. Let us solve this using the same concept. So this is what I can say. This is the top surface of the tank. Suppose this is inside. I'm not drawing the total tank. This suppose inside tank we are seeing. Okay, and then this is the triangle. Yes, this is the triangle. Okay, so what is written? Let us see the question. The top vertex is 1.5 meter below the surface. Now this distance is how much? This distance is 1.5 meter. And then the base is how much? The base is 2 meter, height is 1.5 meter for this particular triangle. So this I can say is 1.5 meter, and the base is how much? The base is 2 meter. How many can say what will be the h bar? Tell me, what will be the h bar in this case? What is h bar? H bar is the distance of the centroid from the top surface of water, or in this case I can say the oil. What will be h bar? Please mention in the comment section. First of all, locate the centroid. Bhavya is correct. I'll explain. You see, this is the centroid, right? This is the centroid. Now we know that centroid. We know that centroid is located where? At 2 by 3h from the top. Now the h is 1.5. The h is 1.5, right? So I can say that this distance will be how much? What I can say about this? This distance will be equal to 2/3 of your 1.5. That is equal to 1 meter. So I can say from top it is how much? 2.5. From top it is 2.5. Very easy. Always take h bar from where? From the top surface. Okay, very good. Now the force will be how much? The pressure into area. Now the pressure is gamma into your h bar. Here I will not use gamma W, I will use what? The gamma of what? The oil. Now what will be the gamma of oil? That will be specific gravity into gamma W, right? Yes. You see, what is specific gravity? Specific gravity is the unit weight of a particular fluid divided by what? The unit weight of water, right? So from here I can say the unit weight of that particular fluid will be the specific gravity into unit weight of water. And then I'll multiply the area. So very easy now. Specific gravity is given 0.8. I will take gamma W as 9.81 kilonewton per meter cube. The question is asked in what? Kilonewton. So I'll take in what? Gamma W in kilonewton per meter cube. And then area. Sorry, here h bar is also there, sorry. H bar and then area. So what is h bar here? H bar is 2.5. Now what is the area of this? The area of this will be equal to half base into height, giving me how much? 1.5. So what is the answer? Tell me. So what is the force? Tell me. What is the total pressure force you are getting? What is the total pressure for getting a value of 29.43 kilonewton? Getting how much? 29.43 kilonewton. Now see, they have not asked to the location of application of what? The total force. That is the center of pressure, right? They are not asked here, but I will explain to you how to find out. Because just because they have not asked in this particular year, doesn't mean that they will not ask in the next examination, right? So therefore, how to find out the center of pressure? This is what? Center of pressure means what? Where? Center of pressure, I can say where I get the total pressure force. This is how we find out. This is h bar. You have got your h bar, centroid location, plus the moment of inertia. The moment of inertia, okay, divided by area into h bar. Okay. So how to find out this? H bar is how much? We got 2.5 plus Ig. Now what is the moment of inertia? What is the moment of inertia of a triangle? It is base into height cube by 36, right? Okay. Then I'll divide the area. Area is how much? Half base into height and then h bar. Yes. So if you put this value, you see b gets cancelled. This becomes 18. This h get cancelled. I get a h square. So I can say h square by 18 h bar. How much are getting this value? Okay. This value how much I'm getting? The height of the triangle is 1.5 square divided by 18 into h bar is again 2.5. So how much are getting this value? Tell me. And final answer, tell me. Beast incarnate has found out. Other students also gave me the answer. Almost 0.05. Okay, so I'm getting how much? 2.55. 2.55 from the top. So see, just because they have not asked in this particular year, doesn't mean that they will not ask in the next year. Yes. So I can say here that here we are finding the pressure and then we are finding the force. But the force application is somewhere here, right? This is the center of pressure. I can say this is your center of gravity and this is your center of pressure. This is your center of pressure. Now if you want to solve such more questions, I have taken all the lectures of fluid mechanics and they are available in recorded format in our BYJU'S Exam Prep app. If you download the app and you go to what? Learn with video lessons. Okay. Hope you are all enjoying these sessions, right? If you are enjoying the sessions and you are finding the sessions helpful and also you are finding that the learning is very easy for you, you are liking the language of mine. Okay, so what will be my request? My request will be that you please once go to Learn with Video Lessons in the BYJU'S Exam Prep app. Because obviously, see, obviously, can I complete the whole fluid mechanics in this YouTube? Is that possible? No, that is not possible. I am just completing the important portions, right? So if you want to access more lectures, all the lectures are available in the Learn with Video Lessons BYJU'S Exam Prep official app. There you can see I have solved more than 500 numericals. I have solved more than 500 numericals for fluid mechanics in this manner. Okay, so it will help you more for your upcoming exam. And this is coming how much? It is coming 2.55 meter. It is coming 2.55 meter. Now, if you have inclined, okay, here we didn't discuss the inclined thing, right? Okay, suppose we have a fluid surface like this, and suppose we have a inclined plane, and suppose it is a rectangle, okay, rectangle, and suppose the area is something like this, 2 meter into 3 meter, this 2 meter into 3 meter. So tell me, this dimension will be how much? This will be 3 meter, like, you're able to imagine this. You see, is looking like this. If you see this, this is 2 meter, this is 3 meter, right? This is 2 meter, this is 3 meter. If you incline, then you will look the 3 meter side, right? The 3 meter side will be visible to you, right? And suppose this depth is given as 1 meter. This depth is given as 1 meter, and if you extend this, suppose this theta is given as 30 degree. This theta is given as 30 degree. So if it is inclined, how to find out the answer? Okay, that's very easy. First of all, you see the centroid of this rectangle will be here, right? It will be somewhere here. Okay, I can say it will be somewhere here. So it will look like this in this particular view, right? So I have to get my depth of the centroid. So can I say this is your h bar? Can I say this is your h bar? Yes, ladies and gentlemen, this is your h bar, right? Ladies and gentlemen, this is your h bar. Can you get me the h bar? Can you give me the h bar? How to find out the h bar? Very easy, you see. Very easy. So this is 30 degree, right? So see this triangle. See this triangle. Yes. See, this will be 1.5 meter. This is your theta. Yes. And suppose this is your x. So x by 1.5 is your sine theta, na? X by 1.5 is sine theta, na? Yes. So can I say your x will be sine 30 into 1.5. Sine 30 is 0.5. So it makes how much? 0.75. So this x is 0.75. You see, that means this is 0.75, right? And this is 1. So what is h bar? You're getting h bar as 1.75 meter, right? You're getting h bar as how much? 1.75 meter. Okay. So if h bar is 1.75 meter, then what I will do? Very easy. Suppose this is water. Gamma W is 9.81. If some other thing is given, then I will do what? Just specific gravity into the gamma W. So here the pressure force will be how much? The pressure force will be equal to gamma W into h bar, right? Into what? The area. Area is how much? 6. So how much you are getting this answer? Tell me, what is the force you are getting in kilonewton? Tell me. What is the force you are getting kilonewton? You are getting a force of 103 around, approximately getting 103 kilonewton. Okay, 103 kilonewton. Now if you want to find out the center of pressure location from the top, the formula changes a bit. It will be h bar plus Ig sine square theta, right? Ig sine square theta by your A h bar. Your A h bar. You see, just the variation is what? This sine square theta. And you see, actually the original formula is this. Now what happens when it is vertical? When it is vertical, can I say this angle becomes 90 degree, and therefore this sine square 90 is 1. So formula changes to what? Ig by A h bar. Understood? So if I apply this formula, what is the answer? Tell me here. H bar is how much? H bar is 1.75 plus Ig is how much? What is your Ig? Ig is what? You can find out, right? It's a rectangle. So I can say BD cube by 12. So 2 into 3 cube by 12. Right? So I can say this is how much? And again, actually you can divide this. See, when you're solving this question, I will give you a small hint to solve faster, okay? So what you can do is, see, this Ig is what? It is BD cube by 12, right? It is BD cube by 12. And area is BD. So what you can do, you can cancel this b, you can save some time. It's actually d square by 12 I can say, right? It is d square by 12, sorry. D square by 12, so I can say 3 square by 12. H bar is 1.75 and sine square 30 will be 1 by 4. So how much you're getting? 1.86 you are getting. Getting how much? Everybody is getting 1.86? Almost you're getting. Let me just calculate this. 9 divided by 4 divided by 12 divided by 1.75. Yes, I am getting almost 1.86. Or I can say, to be accurate, 1.857. Getting how much? 1.857. Understood? Understood? So I can say this is H bar. You see your CP, or I can say HP. The HP will be always more than your H bar, na? Because you see, this H bar is equal to what? This HP is what? Your HP is, Rahul is telling thank you so much, sir. That means what? He got some very good understanding of the subject. And I think other students are also enjoying this session like anything. Okay, how many thought that this previous year question session will be this enjoyable? Because I don't only solve previous year question. Yes, I always, make you understand the other things which surround the previous year questions. Right? And that is the right way to use what? That is the right way to use your previous year questions. Okay? Solve the previous year question and also understand what all extra things they can ask from that particular topic. Right? So HP is how much? You're getting 1.857. And always understand that your HP will be always greater than your H bar, right? It will be always greater than H bar. Why so? Because you see this HP is H bar plus something. Yes, it is H bar plus something, right? Okay, very good. So this is how you find out what? The hydrostatic force in inclined and your vertical surface. The curved surface will be little complicated. I cannot complete in this lecture. Some other day I will take a lecture on that, or you can visit the app. There I have completed. You can see that curved thing. Okay. So this was about hydrostatic forces. Let us solve a buoyancy question. Let us solve a buoyancy question. Okay. Now what is your Archimedes principle? What is your Archimedes principle? What is your Archimedes principle? Tell me. Just remember this principle, you can solve questions on what? Buoyancy. Just remember this principle, you can solve questions from buoyancy. What is the Archimedes principle? The buoyant force on a floating body, the buoyant force on a floating body is equal to the weight of volume of fluid displaced. Volume of fluid displaced. If it is water, then volume of water displaced. Okay. Now see, many students think that, sir, this thing I know from childhood. You see, this civil engineering, mechanical engineering is actually the things which you learn in your childhood only. It is an application thing, right? It's an application thing. If you see most of the strength of material, or you see, try to understand. Tell me, mechanical engineers also can relate to this. Okay, I have very good mechanical friends also. You see, mechanical engineering starts with what? Engineering mechanics, and then strength of material, right? Yes, and fluid mechanics. Now tell me, it's at the end mechanics only, right? If you see, it is at the end mechanics only. And if you see theory of machines or design of machine element, actually it is applied strength of material, right? Yes, it is applied strength of material. And if you see civil engineers, design of concrete structures and design of steel structures is applied strength of materials. Yes, am I right or not? Both mechanical and civil can comment, right? And you see thermodynamics, if you see, the thermodynamics also are based on the basic law of thermodynamics which you learned in your childhood, right? Even thermodynamics are based on the basic law of thermodynamics which you learned in childhood, and I can say it is improvisation. It's an improvisation of your basic laws. Okay, and same thing can be told about production or industrial also. Yes, and therefore always, whenever you are learning a topic and you want to become very good in your numerical solving, the basics has to be understood very nicely. So you see how by just applying this particular Archimedes principle, we can solve any question of what? Your buoyancy. This is the question. You see, a 15 centimeter length of steel rod with relative density of 7.4. So we have a steel rod like this, okay. It has a relative density, you can say specific gravity, same thing, of 7.4. It is submerged in a two-layer fluid. Bottom layer being the mercury, top layer being the water. The height of top surface of the rod above the liquid interface, and this height is 15 centimeter. I'll show the situation here. You see, here we have water. Okay, and here we have your mercury. Okay, so it is inserted like this. This is the steel rod, okay, and then its specific gravity is how much? It is given 7.4, right? It's given 7.4, right? 7.4, okay. And what is the specific gravity of mercury? They have not given. That means they expect that you should know. What is the specific gravity of mercury? 13.6, you should know this value. See, sometimes they give in the examination, sometimes they don't give. And obviously water has a specific gravity of 1 only. Okay, 1 only. Now how to solve this type of questions? I just give you that, I will not give you any formula for this. I will make you understand how Archimedes principle is applicable here. You see, this steel rod, okay, they're asking what? See the question now, the height of the top surface of the rod above the liquid interface. You see, this is the interface, right? This is the interface, means of the both the liquid, right? Interface, this is the interface. They're asking you this height, top, okay, from this interface, right? I can say, suppose this is x. If this is x, suppose this is your x, this will be how much? This will be equal to your 15 minus x. Yes, it will be 15 minus x. Yes, 15 minus x, because total length is 15 centimeter, 15 minus x. You see. If you see this rod, okay, what are the forces acting? The forces acting are its own weight, okay, own weight. Then there will be two buoyant forces, right? The first buoyant force will be due to water, right? Because it has displaced some amount of water, right? And the second buoyant force, okay, the second buoyant force is what? Is due to the force from mercury, right? Are you seeing any other force here? No, you are not seeing any other force? Yes. Now, what will be the weight? The weight will be the unit weight of the rod into what? The volume. Yes. Now, that will be equal to unit weight of rod will be how much? The specific gravity of rod into gamma W into what? Volume will be what? Your total height is how much? 15, and then the area of rod. This is the total weight. Now, what will be the buoyant force due to water? Bhavya is correct, but I will solve. Best in the incarnate also found out, beast incarnate, not best, beast. Okay. So, F1 water. Now, what is water? Water buoyant force will be what? The volume of water displaced. The volume of water displaced is this volume, na? Yes. And this volume will be how much? This volume will be equal to, I can say, the area. Height is how much? Height is x. This is the volume. Now, what will be the weight of this much of volume of water? The volume into your unit weight. That is how much? Gamma W. So, I can say this is the weight of water displaced, right? This is the weight of water displaced. Now, the F2. F2 is what? Due to mercury. This is what? This will be the weight of mercury displaced, right? Weight of mercury displaced. Now, how much mercury is displaced? I can say the mercury displaced is this one, right? This is the mercury displaced, right? And this volume will be how much? This volume will be, area is A, and the height is 15 minus x, and then what? Then I can say your mercury unit weight will be how much? 13.6 into gamma W. So now we'll just equate these two things and so many things will get cancelled. You see 7.4 gamma W 15 into A, that will be equal to what? Gamma W A into X plus 13.6 gamma W then A into 15 minus X. See, the area is same from top to bottom, right? So area get cancelled, gamma W get cancelled. I can say 7.4 into 15 is equal to X plus 13.6 15 minus X. You see, now you can easily solve and give me the X. Some students have already solved, okay? But what I wanted to tell here that, okay, okay, thank you very much. Okay, Beast. Okay, very good. That's great. I have derived a formula also for this. Beast is a very sincere student then. So X, how much you are getting? .38. Very good. Now you see, okay. Now you see, Beast has given a formula. I have derived a formula for this and I have given in the app. Okay, I have given in the app so that you can solve this kind of question very fast. What is given? You see, A by B is equal to S2 minus SB by SB minus S1. What is this? I can say even I forgot the formula. Even I forgot the formula, but Beast Incarnate remembered the formula. So A is what? You see? Correct me, Beast, if I am wrong anywhere. So this is A and this is B, right? Yes. This is A and this is B, right? Yes. And I can say B belongs to the body, right? SB belongs to the body, right? And I think S2 belongs to the bottom one, right? Bottom one. And S1 belongs to the top one. So now put this and tell me. Now put this and tell me. A is X. This is 15 minus X. S2 is what? The bottom one, 13.6. Body is 7.4. Divided by body is 7.4. And top one is water, so 1. Are you getting the same answer? Let us see. Beast Incarnate is Gayab. Where is Beast Incarnate? Gave the formula and just ran away. Or what? I think yes, it is the correct one. Same answer? Bravo. Bravo. So in my app, in our app, I have given this formula. Okay. So this is a very standard question which is asked in your gate, and I have given this formula, and you see they have asked these questions. Okay. So there is a, I can say what I wanted to tell from here is that, you see, any topic you pick, any subject, suppose I am talking fluid mechanics. I am talking fluid mechanics. Okay, I am talking fluid mechanics, suppose. The fluid mechanics will be a combination of, I can say, some 400 concepts. There will be some 400 concepts, and actually if you see, this 400 concepts can be, jolted down to actually 150 concepts. Understood? And I can say the rest 250 concepts will be based on what? They will be based on these 150 concepts only. Okay? So I can say any subject can be brought to very less concepts. Now you see Bhavya is becoming shocking. He's shocked. But actually this number appears more because you have not understood the concepts. Now once you understand this concept, now tell me, even if you don't remember the formula, See, even if you don't remember the formula, if you have understood the concept, then also you can solve this question or not. Even if you have not remembered the formula, if you have understood the concept, you can solve the question. Another thing is that if you have understood the concept so nicely, you don't have to, remember everything. Or, the concept will become an integral part of you. See, suppose I ask you that, how is your best friend? You can write 10 lines, ra? If you have a best friend, nowadays people don't have best friends, okay, they are best enemies, but they have no best friends, okay, but suppose if you have a best friend, tell me, do you have to remember 10 things or 20 things about them? No, right? Even your best enemy also, you don't have to remember 20 things or 10 things, right? Because those things become an integral part of you. So you have to make the concepts, you have to make the studies an integral part of you. Make them your constant companion. Okay, then the studies will become fun, and then you will be, busy in solving questions. And when those concepts become a part of your inner thinking, you will not understand. Okay, and for such thing you have to attend the lectures from a person who has made the concepts the integral part of his life, a person like me. Yes, for me, you see, if you see, many times you see the questions which I am framing them on spot, right? Some of the questions I am framing on spot. I am not requiring even the data. How? Because the concepts have become an integral part of me. So if you also want to become a student like me, okay, don't try to become a teacher like me. Okay, many people ask me that, sir, how to become like you? I tell that, don't try to become a teacher like me. Try to become a student like me. If you become a student like me, then you will be benefited. Learn from the student in your teacher. Okay, thank you. Let us go ahead. Hope you are enjoying this lecture very much. In future, we'll conduct some late night sessions also. Okay, many students are enjoying the sessions. Okay, so now the next topic we'll see is dimension analysis. The next topic we'll be discussing is dimensional analysis. In dimensional analysis, the most predominant question asked is on Froude number model. Okay, on Froude number model or Froude number similarity. Froude number similarity. I am some water. Late night marathon. Yes, we will start soon. Don't worry. Okay. Let the exam come sooner. Closer, not sooner. Let the exam take some time, not come sooner. Let the exam become closer, and then the marathons will increase. Okay. It's very simple. Okay. We will solve some questions, and by questions only you will be able to solve other questions. So what is a Froude number similarity? If we have a model and a prototype, okay, model and the prototype. Now among this model and prototype, I can say the actual structure is your prototype. The actual structure is the prototype, and model is a small version of it, right? So suppose I have a model like this, and I have a prototype or actual structure like this. Then what I can say, there will be some relation between what? Their dimensions. Suppose this is the width, and this is the depth. And suppose this is the width and this is the depth. The width of the prototype and this is the depth of the prototype. This is the depth of the model, this is the width of the model. So you can say this ratio of model and prototype, this ratio of what? Prototype or model, or I can say vice versa. Suppose I am telling prototype by model. This will be equal to the depth ratio also, and give what? A name LR. I am very jolly. Yes, I am very jolly because my life is surrounded around what? Around beautiful students like you. When you are constantly with what? Beautiful students like you. And beautiful doesn't mean your face is beautiful. I am not able to see your faces. Okay. So I will not say that your faces are beautiful. Okay. I don't know. Might be beautiful also. Okay. But you all are trying to do something in your life. You want to prove yourself, right? Many of you are trying to prove yourself. You are trying to achieve something. You are trying to, make a point. You are doing a sincere effort on your part. Yes. So that is very beautiful thing. Yes. Okay. That is the very beautiful thing. Okay. So please continue that. Yes. And therefore I am very happy because I am always with you people. Okay. So this is what, okay, CS is asking that what about case varies with model prototype. Means you are asking about distorted model, right? Distorted model, right? I'll explain that later. But here it is LR. Let us first discuss this. This is your LR. Means the ratio of the dimensions. Length ratio, I can say. This is what? I can say this as length ratio. I can say this as length ratio. Now you see what happens here. When I'm saying about fluid number similarity, that means what? Fluid number, that is what? Velocity by root under G into your hydraulic depth. So for the model will be equal to that of what? Your prototype. So I can write like this. Okay. Both are same. The fluid number for the model and prototype same. Now see the G will be same. You see the model or prototype, the G will be same. Okay. Yeah. We applied this to only, open channel flows. Okay. We have, for other things, we have Reynolds model similarity. I'm not solving so much questions on Reynolds model similarity. If you visit the app, there I have solved questions from Reynolds model similarity also. Okay. In that, the Reynolds number will be same, right? Okay. So here what happens? The ratio of the velocity will be what? Will be square root of hydraulic depth of prototype and model. Now this is a length ratio, right? So I can say this will be what? Length ratio. And I can say that your velocity ratio in fluid number similarity is what? The length ratio to the power half. Yes, very simple thing. Okay. Now, if I ask you for your time. Now what is time? Time is what? Time is length by velocity, I can say. Distance by velocity, I can say, right? So, if I'm taking time ratio, means time taken in the prototype and time taken in the model, that will be what? Length ratio and velocity ratio. So, this is length ratio. Velocity ratio is what? Length ratio to the power half. So, this becomes what? LR to the power half. Now, why I'm deriving this thing, many students get confused. They ask me, sir, how to remember? Don't remember. You can find out in seconds, right? Don't remember. You can find this out in seconds, right? See, time is what? Length by velocity. Okay. These things you can find in seconds if you have understood the concept. And that's what I told. See, this is the single concept. Yes. This is the single concept. If you know this concept you can find out. This concept you can find out, right? If I take the ratio of acceleration is what? Velocity by time. So velocity ratio, time ratio. That means what? LR half, making it what? 1. So as per fluid number similarity, your acceleration in the prototype or actual structure will be equal to what? Acceleration in model. Because what is this? This is prototype by model. Again you see, these concepts comes from one single concept, right? Now coming to discharge. What is discharge? Discharge I can say is area into velocity. Area into velocity, right? So what is area ratio? So I can say QR, the ratio of discharge will be what? Area ratio into velocity ratio. Now area is what? Length square. And velocity we got is what? Length to the power half. This becomes what? Length to the power 2.5. Yes. So you see, I just had idea of one basic definition, that fluid number is same. So from here you see, I found out concept number 1, right? Concept number 2, concept number 3, concept number 4, and even I can find out more. If there is one lecture I have taken on fluid number similarity, you can visit that. And there I have taught the distorted model also, okay? Distorted model means when the length dimensions are not same in the vertical and horizontal direction, okay? One student was asking, so you can visit the YouTube channel. There I have taken a lecture on fluid number. Or you can search in Google, in YouTube also, fluid number Satyajeet Sir. you will get that distorted model also. Okay, I have taught in the end also, and I have also pinpointed the time where I have taught that also. Okay, so you can visit that and you can see. Okay, so that this now many students would have understood when I told that 150 concepts gives rise to 400 concepts. Understood what I mean to say? Understood what I mean to say? That if you understand some concepts very nicely, from there you can find out what? New concepts. From there you can find out new concepts. So see this previous question. See, very simple question, you see. Very simple 1 mark question which was asked in GATE, that if there is fluid dynamic similarity, which of the following relationship is valid? The answer is what? The answer is D. Yes, the answer is D. VR, velocity ratio, is LR to the power 0.5. Okay, now solve this question. Okay, solve this question. Chalo, let us solve this question. 2 mark question asked in GATE 2007, because we are discussing IIT Kanpur previous year question. So please solve this question. We have also pipe flow coming up, so please don't go away. A 1 in 50 model means what? I can say LR is 50. Okay. Now they have written Ogi, spillway, whatever, doesn't matter. Just a hydraulic structure. Acceleration is this. What is the answer? Okay, the option is not mentioned. The option is mentioned wrong here. Okay, the question is little wrong. Okay. Some typing mistake has happened. Sorry. Some typing mistake has happened. Okay. So tell me the answer. Okay, the acceleration is 1.5 only, right? Okay. The acceleration in the prototype will remain 1.5. There is some error in the question. No issues. Okay. Sorry, some question is some typing mistake is there. Okay, I think this question will be better. Please solve. Mechanical 2001 2 marks. Please solve this question. Very straightforward question. Please solve this question. A 1 in 50 model of spillway, the discharge was measured to be 0.3. The discharge is 0.3. The corresponding prototype discharge is in meter cube per second. Now this question is short. 3K marks. Okay. So here your LR is 50. So tomorrow session will be little heavy. Today was the beginning of the series, so therefore I made it little light, okay, and I choose the easier topics. Okay, I didn't want to burden you in the starting only. Tomorrow we have a very burdened session. So tomorrow I expect that all of you have a very good rest in the afternoon or morning, so that evening, when not evening, night, when 10:45 I solve the questions, then you are ready. Okay, very good. Let us solve the questions. So QP by QM, that is QR, is equal to LR to the power 2.5. I can say that is what? 50 to the power 2.5. So QP will be equal to 0.3 into 50 to the power 2.5. We're getting how much? Almost 5303. So very straightforward question. Okay, very straightforward question. Let us go to the next topic, that is what? Your what? Your pipe flow. Okay, the last topic for today, pipe flow. Okay, and coincidentally they have asked question in 2015. IIT Kanpur asked 2 questions in civil, okay, which covers all the concept. Okay, so I can say it is a coincidence that they have given a very good question. Okay, so I'll solve that question so that you understand many things. In pipe flow, first of all, to understand that the friction loss, that is the major loss. The friction that is the major loss is how much? That is equal to FL B square by 2GD, right? If you have a circular pipe, right? And if you are finding this in what? In your terms of discharge, this becomes what? FL. Discharge is what? Q by discharge is V is what? V is your Q by area. If a circular pipe is there, that means what? It is Q by pi by 4 d square. So when you make it square, b square, then this also becomes square. So I get how much? Q square by 2g pi by 4 square. And then this is d square to the power square. D to the power 4, already a d is there, d to the power 5. Yes. So how much are getting this? FLQ square by, if you solve this, you're getting 12.1 d to the power 5. So some questions you are going to use this formula, and some questions are going to use what? This formula. Okay, the friction loss. Okay, now let us solve some questions. Not one question asked in the previous question, that will cover a lot of concepts. Okay, this is a question. Okay, two reservoirs are connected through a 930 meter long. Okay, so we have suppose reservoir 1 here, and we have a reservoir 2 here. Okay, so now we are connecting them. Okay, very good. The length of the pipe is 930 meter, and it is diameter is 0.3 meter, which has a gate valve. Somewhere here there is a valve here. Okay, the pipe entrance is sharp. Okay, so at entrance we have a loss coefficient of 0.5, and the valve is half open, and the valve has a loss coefficient of 5.5. This valve has a loss coefficient of 5.5. Don't worry, I'll explain the things. Okay, the head difference is given 20 meter. The friction factor is given 0.03. G is given 10 meter per second square. You have to find out the discharge, accounting for both minor and major losses. So it's a good question. Let us solve this. Asked in 2015. Let us solve this question. Now, if you are feeling that, okay, sir, this question was asked in, civil, why you are solving for us? See, don't think that they will differentiate between civil and mechanical, okay? Sometimes they have asked in civil, the next time they will ask in mechanical, okay? So the level difference is how much? The level difference is 20 meter, right? The level difference is given 20 meter. Understand this question very carefully. If you understand this question very carefully, you will understand many things. So this is the total head loss, right? I can say this is total head loss, right? This is the total head loss. This is the total head loss. Very good. Now see, we have connected a pipe. And we have a valve here. Suppose a valve is there. Now what type of losses will occur here? There will be one friction loss here. Yes. Let me write down the losses in green. There will be a friction loss here. Yes. Then there will be a valve. So I can say some valve loss is there. Okay. If there is a valve or there is a bend, then there will be some losses. There's a fitting, I can say. There's fitting loss. This is a fitting. So I can say this sort of a fitting loss will happen. Here there will be what? There will be entrance loss, because the water is entering the pipe. So there will be entrance loss, and here the water is exiting from the pipe. There will be exit loss. Understood? Any other loss you are able to see? No, there is no other loss. Now the total head loss is 20, and that will be equal to first the entrance loss. The entrance coefficient is given how much? 0.5, and we know that entrance loss is what? 0.5 b square by 2g. Yes. So entrance loss done. What is the exit loss? The exit loss is b square by 2g. The exit loss is what? B square by 2g. Remember that entrance loss is actually coefficient. Actually coefficient into b square by 2g. It is given how much? It is given this. Okay. Very good. So we got our entrance loss. We got our exit loss. Then there is fitting loss, and the fitting loss has a coefficient of 5.5. So 5.5 v square by 2g. The friction loss is what? FL b square by 2g d. Now you see, can you find out the whole expression in terms of b square by 2g? Yes. So this will be 20 is equal to v square by 2g. First is 0.5, second is 1, third is 5.5. And the last one will be, what is FL by D? How much are getting this? F is 0.03 Length is how much? Length was given 930, right? It is given 930 and D is 0.3. D is 0.3. So how much are you getting this? Everything I put in, standard units. How much are you getting this? You are getting a value of 93, right? You're getting a value of how much? 93. So you see how much you're getting this? If you add all these things, it is going to get 93, right? 93. 93. So if you add all of this is actually 6 plus 1, 7. This is 100, na? You see how smartly they have framed the question, so that, how smartly they have framed the question. This is 5. This is 5. So can I say V square will be equal to root under 2G, and G they have given us as 10. And then 5, you're getting how much this as? You're getting V is equal to how much? 2G by 5, sorry, 2G by 5, right? Getting 2 meter per second, right? Yes, 2 meter per second. So easy, so nice. Once you get your V as 2 meter per second, you can easily find out what the discharge. Discharge will be how much? The velocity into the area, pi by 4 into 0.3 square. Now this you have to do some calculation. Getting how much? Tell me. The question is asked in meter cube per second, so 0.1413 meter cube per second. Again, you can see that this is a very good question. Okay, this is a very good question, and incidentally they have asked in the 2015 GATE, and you see here we understood many concepts. So if they ask you a question like this, they will give you two reservoirs. If they give you two reservoirs like this, and they're asking you what? Find out velocity and all, then just take all the losses. Take into consideration all the losses and then equate it to the total head loss. And the total head loss will be how much? The total head loss will be the difference in the level of water in both the reservoirs. Very easy question. Now if they ask you a question like this, you can easily solve in the examination, right? Because you've understood the concept. Now you see a similar question also asked. Okay, similar question also asked. Let us solve that question. That will be the last question for the day. That will be the last question for the day. So you have completed many important topics today. So tomorrow we'll be seeing what? Tomorrow we'll be seeing the heavy ones. Fluid kinematics, okay, fluid dynamics, okay, and then incompressible flow, laminar flow, boundary layer theory, and etc. Okay. Okay, the question is so long. Oh my God. But we'll solve it. Okay. So it's given. Let us read the question first. A pipe of 0.7 meter diameter has a length of 6 kilometer. And connects two reservoir A and B. Very good. Oh, I've already imagined it. The water level in the reservoir A is at elevation of 30 meter above the water level at reservoir B. Understood? Halfway along the pipeline, there is a branch through which water can be supplied to a third reservoir C. Okay. Friction factor is this. Quantity of water discharged into the reservoir C. Okay. Amir know the trick. Okay. That was a good reply. Okay, C is 0.5. Okay. Considering acceleration due to gravity as 9.81 meter per second, neglecting minor losses, find out the discharge in B. So see, a long question, the solution will be less if you draw the diagram properly. So I will draw now. I read the question. So we have a reservoir A here. Okay. And we have a reservoir B here. Very good. And then the level difference between these two reservoirs is how much? 30 meter. It is how much? 30 meter. And we have a pipe connected like this, whose length is 6 kilometer. Okay. Now it is written that halfway we have connected another pipe. Okay. We have connected another pipe to reservoir C. To reservoir what? C. Yes. To reservoir C, we have connected another pipe. Okay. Now what is written here? Halfway along the pipeline, there is a branch through which water can be supplied to a third reservoir C, right? and the water's discharge in the reservoir C is 0.15 meter cube per second. So here it is how much? This discharge is given how much? 0.15 meter cube per second. Now how to solve this question? Very easy. First of all, you see, if you consider from A to B, the total head loss is this one, right? The total head loss is this one. And they have told to ignore what? They have told to ignore the minor losses. So the major loss only remaining is friction loss. So I'll consider the friction loss from this point to this point, right? And from then this point to this point. Yes, I can say this is friction loss 1, this is friction loss 2, right? Right? Why I am differentiating? Okay, somebody has found out the answer also. So why I am differentiating this? Why I am differentiating this head losses different? Because the discharge will be different, right? The discharge will be different. Suppose here the discharge is Q. So can I say here the discharge will be Q minus 0.15 now? You see. Here the discharge is Q. Here it is what? 1.5 mentioned going towards C. So this will be what? This I can say is Q minus 1.5, right? I guess it's not correct. I also don't know. Let us solve it. But I also don't know. I just seen the question. So I just, my team has just given me the question, so I don't know solution. So I don't know solution. I will solve it. Okay. I don't see this. I don't know the solution, so I'll solve it. I don't know the solution, but I know the concept for the solution. So I'll solve it. I don't know. Let us see. So you see, this is Q discharge. This is 1.5 going to C. This is going to B. So if I'm considering head loss from here to here, discharge will be Q. From here to here, discharge will be Q minus 1.5. Oh, sorry, 0.15. Sorry. 0.15. Sorry. So now, but total head loss will be 30 only, right? So I can say 30 will be equal to. What is the head loss here? I'll use the discharge equation. That is what? FL Q square by 12.1 d to the power 5, right? D to the power 5. And then for the second one, I'll use what? FL Q minus 0.15 whole square, okay? Divided by 12.1 d to the power 5. Now the diameter is same throughout. The diameter is same. And you see, it is halfway. That means what? This length and this length will be same. That will be equal to 3 kilometer, right? 3 kilometer, right? And F is also same. So what I can do, I can take this 30 common. You see, again this question is one line answer only, right? Only on based of this line you can solve the question. 30 is equal to F, that is given how much? 0.024, right? Let me see. 0.024 into length. Length will be how much? For the first one, it is 3 kilometer, halfway. For this one also 3 kilometers. So I can say 3 kilometer will be 3000 meter. So 3000 divided by 12.1. Diameter is given how much? It is given 0.7 meter. So 0.7 to the power 5, I can say Q square plus Q minus 0.15 square. Yes. So now I have to solve for Q. I have to solve for Q. Can you solve for Q? Please solve for Q and find out this Q. So if you find out Q, you find out the discharge to B also, right? If you find, it is asking what? Discharge into B. Discharge into B is minus 0.15. So find out discharge into your total one. Means what? Find out Q first. Can you find out Q this? Please solve, or use a calculator to solve, okay? See, this will be, I think quadratic will come, but use a calculator to solve and tell me what is the Q you are getting. I'll also solve. This is getting 35.4. If options are given, you can check, na? But options are not given, so data entry question. So please find out Q, how much you are getting this. The solving question, Lakshmi Rao is getting 0.7215. Let me just put it. Okay, someone else also got 0.73. 73. Okay, Samriddhi also got 73. Okay, very good. So discharge you are getting 0.7215 meter cube per second. But this is not the discharge, right? This is discharge from A. That's branched out. So discharge to B will be, you subtract 0.15, that is what? 0.57. 15 almost, I can say 0.1517 something. Okay. Understood this question? Again, you see the two questions are very similar, right? The two questions are very similar. You have to understand the language of the question and you have to just apply what? You have to just apply the formulas rightly. So you can see these two questions are from pipe flow, okay? And actually two important formulas we used, right? Two important formulas we used. One is the FL B square by 2GD and this is FL Q square by 12.1 due to power 5, right? So thank you very much. Hope you enjoyed this today's previous year question session, where we not only discussed the previous year questions asked in GATE from IIT Kanpur, but we also studied that what other types of questions can be asked. So tomorrow we'll be seeing fluid kinematics, fluid dynamics, right? We'll be seeing boundary layer theory. We'll be seeing incompressible flow. We'll be seeing our laminar flow. Okay. Okay, yeah. So thank you very much. Okay. So thank you very much. Thank you all the participants. Okay. So tomorrow at 10:45, all these tough topics will solve. So we'll have a little long session tomorrow. Thank you very much. Bye-bye.